This video goes through how to find an optimal solution within a feasible region. So we've got an example here where a person called Jenny spends some of her spare time outside of school hours playing netball and also doing a part-time job. So two separate sort of things that she's putting different number of hours into. Each week she has a maximum of 20 hours available for each of the two activities. The number of hours that she spends playing sport is less than or equal to 4 times the hours she spends working, and the hours spent at sport are greater than or equal to twice the hours spent at work. So these three things basically give us our constraints for the problem. So we're going to set the hours playing netball as X, and we're going to spend the hours doing the part-time job as Y. Alright, and we're just going to write down the constraints from that. So the first one is obviously spending a total of 20 hours. Alright, maximum 20 hours. Now that can be written as the sum of X plus Y is less than or equal to 20. The next one, number of hours she spends playing sport is less than or equal to 4 times the hours she spends working. So that's expressed as X is less than or equal to 4 times Y. Alright, and then lastly, you've got the hours spent at sport are greater than or equal to twice the hours spent at work. Okay, so once again, that can be expressed as this constraint here. X is greater than or equal to 2 times Y. Now, the last two constraints are quite common to include, even though they haven't worded it up in the question. We know that X, the number of hours for playing netball, and Y, the number of hours of part-time work, are always going to be above 0 because they're not negative. So these are a common constraint that you often have to include as an inequality in there. Alright, so those are the 5 constraints, and then we've also got our objective function. So this is derived from the last statement. So it says find the time spent on each activity during the week in order to maximize Jenny's earnings. Now she earns $2.50 per hour, and she also per hour of netball, and she also earns $6 per hour working her part-time job. So we can work out her earnings as 2.5 times the number of hours of netball plus 6 times the number of hours of work. Alright, which leaves us this objective function here of z equals 2.5x plus 6y. Often objective functions are written in terms of z being equal to something times x plus something times y. And this will allow us to work out her earnings with different solutions, and we're going to find the maximum earnings that she can get by using all different points within the feasible region. So the first thing we're going to do is plot these inequalities on a CAS. So you're going to open up your CAS, go to Graphs. Once you're on this Graphs page, you're going to press Delete and select option 6, which is Relation. Now you're going to start typing in the inequalities. But the trick here is, if you want the feasible region to be really easily visible, what you want to do is actually flip the sign of the greater than or equal to sign, so it shades the wrong direction. And what this does is it highlights the feasible region as a white zone in the middle, which is a lot easier to see on a CAS. So, for example, the first one will be x plus y is, we're going to change it to greater than or equal to 20. Okay, and I'm going to hit enter. Now, when I want to add a new one, I'm going to hit tab. And it says relation 2 now, and I'm going to put the next one in. So I'm going to hit x is greater than or equal to 4y. Okay, I can only see one at the moment, so when I zoom in, I'll be able to see the others. Press tab again. Okay, so they're all plotted now, and I'm going to zoom out so I can see it properly, because the white region's slightly out of view. So I'm going to press zoom out, and I'm going to go to roughly the middle of the white region. I'm going to click down. Okay, so I can clearly see my white region now. Now what I want to do is I want to highlight the corner points, and I want to see what those values are. So I'm going to go to Menu, Analyze Graph and Intersection. Then I'm going to click on two of the lines. I'm going to click the red and the blue to start with. It gives me this little scanning tool, which I just click down and slide across there. I've got to do that for each of the corner points there. So, okay, now what we can do next is actually calculate what each of these combinations of hours would do to Jenny's earnings. So we're going to actually substitute in those values into the objective function. So that's where we're going to write down two different calculations. We're going to write down Z is equal to 2.5 times X, which for the point there is 16, plus 6 times Y, which is 4. And that will give us the value of Z for that corner point. And that's one of our maximum values that we can get. So if I come out of this page and go to calculate mode and type that in, 2.5 times 16 plus 6 times 4 gives 64 as the earnings for that combination. And then the other combination we're going to check is the other corner point. Now this is assuming she can work not a whole number of hours. So there's a different solution if we do it for a whole number of hours, and I'll include that in a separate video. So assuming she can work these hours, we're going to go 2.5 times 13.3 plus 6 times 6.67. Alright, so slightly more money earned doing that way. So her best option is to do 13 1/3 hour there and 6 2/3 hours there. Now, in the context of the problem, it might not always be sensible to work a decimal number of hours, okay? And there's actually a separate way of working out, if you are limited to whole numbers, working out what the maximum is for that.